Question 1a. Factorize x squared minus x minus 2. So we can factorize this quadratic into double brackets. We need two numbers that multiply to give 2, so that's 2 and 1. To get x squared, we do x multiplied by x, and to get minus 1x in the middle, we need minus 2 plus 1. 1b. Hence or otherwise, show that x squared minus x minus 2, which we looked at in part A, is a factor of f of x. We have shown in part A that x squared minus x minus 2 can be written as x minus 2 x plus 1. So if we can show that x minus 2 x plus 1 are factors of f of x, then we can show, as the question asks, that x squared minus x minus 2 is also a factor of f of x. So we're going to use the factor theorem to prove that x minus 2 and x plus 1 are factors. So from x minus 2 and x plus 1, we know that the solutions from this would be x equals 2 and x equals minus 1. When I say solutions, if we were to substitute these values into f of x, we should get 0. And we can show that now. So if we do f of 2, substitute 2 into f of x, we get 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6, and if you work all of that out, you do get 0. If we also substitute in f of minus 1, so the other factor from here, we should also get 0. So minus 1 cubed plus 2 minus 1 squared minus 5 times minus 1 minus 6, and that also gives us 0. So we have shown that 2 and minus 1 are solutions to f of x, which has shown x minus 2 and x plus 1 must be factors of f of x. So we need to write in conclusion, so as x minus 2 and x plus 1 are factors of f of x, then so is x squared minus x minus 2. An alternative method for solving part B would be to do algebraic long division to show it is a factor. So we would be dividing x cubed plus 2x squared minus 5x minus 6 by x squared minus x minus 2, and if there's no remainder, then it would prove that it is a factor. So to do algebraic long division, how many times does x squared go into x cubed? It goes in x times, and then we do x times this whole expression on the left hand side. So x times x squared is x cubed, x times minus x is minus x squared, and x times minus 2 is minus 2x. Draw a line, subtract, so x cubed minus x cubed cancels, that first part should always cancel, plus 2x squared minus minus, so that's going to be 3x squared, minus 5x minus minus, so that's going to be minus 3x, and then bring down the minus 6. And then how many times does x squared go into 3x squared? Goes in 3 times. So then we do 3 times the whole expression on the left, so we're just repeating again. So 3 times x squared is 3x squared, 3 times minus x is minus 3x, and 3 times minus 2 is minus 6. So there is no remainder, which shows x squared minus x minus 2 is a factor, because we would just multiply it by what we've got up here, which is x plus 3. And finally, one more method we could have used is similar to the last method where we did long division. If we are showing that x squared minus x minus 2 is a factor of f of x, then we know we must multiply it by something to get this f of x. And we know this something must be a linear term because we want to get x cubed at the start. So therefore we need to times this x squared by an x to get the x cubed term. And then to figure out what goes on the end of this bracket here, we just look at the number on the end. How are we going to get from minus 2 to minus 6? Well, we must multiply by 3. So therefore we get straight to x plus 3, which is the answer we got from the long division. You must state there is no remainder when dividing f of x by x squared minus x minus 2. Question 2. Given that 4 plus 2 root 3 over 5 minus 2 root 3 can be written in the form a plus b root 3 over c, where a and b are integers and c is prime, find the value of a, b, and c. Okay, so this question is similar to GCSE style question where we are rationalizing the denominator. You need to times both the numerator and the denominator by the conjugate, so this expression but the opposite sign, by the conjugate of the denominator. So times by 5 plus 2 root 3 over 5 plus 2 root 3. And then multiplying fractions, you just multiply at the top. You don't need to put the bracket in, but it's the same as expanding a double bracket. So we've got 4 plus 2 root 3 times 5 plus 2 root 3 on the top. So 4 times 5 is 20. 4 times 2 root 3 is 8 root 3. 2 root 3 times 5 is 10 root 3. And then 2 root 3 times 2 root 3. Well, the 2 times 2 is 4. And root 3 times root 3 is just 3. So that's 4 times 3. And on the bottom, this will be the difference of two squares, hence why the surds will cancel out. So we only actually have to do the 5 times 5, which is 25, and the last term, which will be minus 2 root 3 times positive 2 root 3, so that will be minus, again, 4 times 3 on the bottom. So if we simplify this, we've got 20 and we've got a 12 on the end, so that's 32. We've got 8 root 3 plus 10 root 3, so that's 18 root 3, all over 25 minus 12, all over 13. Question 3. In triangle ABC, AC equals 7 centimeters, BC equals 10 centimeters, and angle BAC is 65 degrees. Find to the nearest 0.1 degrees the size of angle ABC. Okay, so firstly I'm going to draw the triangle just to allow me to visualize it a little bit better. So if we call this A, B, and C, so we know that AC is 7 centimeters, BC is 10 centimeters, and we know angle BAC, so BAC, this one is 65 degrees. Find the nearest 0.1 degree, the size of angle ABC. So we want this angle here. So it's not a right angle triangle, so we've got two options. We could do sine rule or cosine rule. The sine rule, we would need two pairings, which we do have. So sine rule, sine 65 over 10 equals theta over 7. And if we rearrange that, theta is equal to sine 65 over 10 multiplied by 7. Stick that in your calculator, make sure it's in degrees, and we get 39.4 to 1 decimal place. Okay, part B. Find in centimeters squared, 3 significant figures, the area. So the area of a non-right angled triangle is a half AB sine C. Thing to note here is the angle must be between the two sides that we have. So we have the side 7 and 10, so the angle between them is this one, which we don't know, but we can find it. If I just draw that triangle a little bit bigger, This is 65. This is 39.4. So we can figure out what this third angle here is by doing 180 minus 65 minus 39.37, which is equal to 75.63 degrees. So now we have this angle between the two sides, 7 and 10. So substituting into the equation, a half times 7 times 10, or 10 times 7, doesn't matter, times sine of the angle we just found, the angle between them, which is 75.63 degrees. And if you stick that in your calculator to 3 significant figures, we get 33.9. Question 4. Figure 1 shows a sector OAB of a circle where angle AOB is theta. The circle has center O and radius 15. The point C divides OA in the ratio 2:1, and the point D divides OB in the ratio 2:1. The area of the region ABDC shown in the figure is 100 centimeters squared. Find the value of theta. Okay, so part A. If OA and OB are shared in the ratio 2:1 and the total radius of that is 15, then OC has to be twice as big as CA, and it must add to 15, so that must be 10 and 5. Same on the other side with OD and OB. So if we want to find theta and we are given the area of the shaded section, well, the area of this shaded section is going to be the area of the whole sector subtract the area of the smaller sector. So if we do the area of the large sector, so it's the theta over 2 pi, so what proportion of the circle, multiplied by pi r squared. So the big sector has radius 15, and we then are going to subtract the area of the smaller sector, which is again theta over 2 pi times pi r squared. This time the radius for the smaller sector is just this bit here, is 10, so that's times 10 squared, and that is equal to the shaded section, that is equal to 100. Simplifying this first bracket, the pi's cancel, so we get 15 squared, which is 225 over 2 theta, subtract, again the pi's cancel in the second bracket, 100 over 2, so 50 theta equal to 100. If we multiply everything by 2, we get 225 theta minus 100 theta equals 200. And then to solve this, we can factorize out the theta on the left hand side. So we end up with theta 225 subtract 100 equals 200. And then we can rearrange to say theta equals 200 over 225 minus 100, which is 125. So if we work that out, theta is 1.6. Question 4b. The perimeter of the region ABDC. ABDC. So that's the shaded section. So for that is going to be made up of 2 arcs, the arc AB and the arc CD, plus CA and DB, which are both 5. So we know it's going to be 5 plus 5 plus the 2 arc lengths, AB and CD. Now the arc length is the proportion of the circle, which is theta over 2 pi, multiplied by the circumference of the circle. The circumference of the circle is pi d, or 2 pi r, and if you simplify this, you'll notice the 2 pi's cancel out, and the arc length is just r theta. So for the arc length AB, we need to do the radius, which is 15, times theta, which we've worked out to be 1.6, plus the arc length for CD. The radius OC is 10 times theta, which is 1.6, and if we work all of that out, we get our answer for part B to be exactly 50 centimeters. Question 5. Given that f of x can be written in the form ax minus b all squared plus c, where a, b, and c are constants, find the value of a, b, and c. Okay, so when we're writing something in this form, it means we need to complete the square for our function, which is 3x squared minus 9x plus 5. So when we complete the square, we want to write it in the form x plus b over 2 all squared minus b over 2 all squared plus c. But firstly, we need to make sure the coefficient of x squared, the number in front of x squared, is 1. So we need to take a factor of 3 out of these first two terms. You can take a factor of 3 out of all three terms and complete the square for all of it, but it's a bit faster if you just do it for the first two terms. So x squared minus 3x, and then leave the plus 5 on the end. So now we just need to complete the square for this bracket here. So it's going to be 3, open a big bracket because it's 3 times whatever we get, and now we're going to use this formula for completing the square. So x plus b over 2, well, b is a negative, so it's minus 3 over 2 all squared minus, put this bit in a bracket, b over 2, which again is minus 3 over 2 all squared, close that bracket, plus c on the end, so plus 5. Okay, so we're going to multiply what's in the bracket by 3, so we get 3 x minus 3 over 2 all squared minus, well, minus 3 over 2 times minus 3 over 2 is 9 over 4, but multiplied by the 3 is 27 over 4 plus 5 on the end. Okay, so we can simplify these two numbers on the end. If we just do it without a calculator quickly, you could use a calculator. We get minus 27 over 4 plus 20 over 4. And if we write that up here and simplify it, we get 3 x minus 3 over 2 squared minus 7 over 4. The reason I wrote the 5 as 20 over 4 was to make it easier to simplify this. Okay, so that's part A done. So that is what our function is equal to if we write it in this form. So part BI, hence write down the minimum value of our function x. Okay, so if you imagine we plotted this function on a graph, okay, it said y equals this, or this, because this is the same thing, we've just written it in a different format. We want to imagine what is the smallest value we can get for this function. Well, if you look at just this first part of the function, it is a squared term. So the smallest anything can be that is squared is 0. Okay, you cannot get a negative if it is squared. So if you make this first part 0, minus 7 over 4, the smallest our function can be is minus 7 over 4. 0 minus 7 over 4. So that will be the minimum value. BII, the value of x at which this minimum occurs. So we said in part I, we were going to make this part of the function equal to 0. That's the smallest this part can be. Now, how do we make this part of the function 0? What value of x are we going to use? Well, we need to use x equals 3 over 2. And then 3 over 2 minus 3 over 2 in this bracket gives us 0, and 3 times 0 is still 0. Okay, so when x is 3 over 2, y is minus 7 over 4, and that is the minimum value of our function. Waiting. Warming up, okay. Starting in 5, 4, 3, 2, 1. Question 6. Figure 2 shows a lawn ABCDF where ABDE is a rectangle of length y and width 2x. Each end of the lawn is a semicircle with a radius x. The lawn has a perimeter 90 meters and area S. Show that S can be written in the form S equals kx minus pi x squared. Okay, so let's start off by writing an equation for both the area and the perimeter of this shape. So area is going to be the rectangle, which is simply going to be length times width. So y multiplied by 2x plus the area of both semicircles. Now we can just do a full circle because that would be both added together. So that would be pi times the radius, which is x squared. So the area can be written as 2yx plus pi x squared. Okay, and let's now find the perimeter of this shape. So that's going to be the circumference of the circle. Again, we can just use the full circle because it's two semicircles, plus 2 lots of y. So let's start with 2y plus the circumference of the circle, which is pi times d, or pi times 2r. So pi times 2x, because r is x. We know this perimeter is equal to 90 because it tells us that in the question. So now we need to write the area in the form S equals kx minus pi x squared. Now you'll notice there isn't a y in this, whereas the equation for the area that we have has a y in it. So what I'm going to do is rearrange the equation for the perimeter to say 2y equals, so rearrange this one to say 2y is equal to 90 minus 2 pi x, and I'm going to substitute this into the formula for my area, and that will eliminate the y, and I will have the area just in terms of x and constants. So the area, which is S, equals 2y, which I can now write as 90 minus 2 pi x, multiplied by x, just substituting in for the formula of my area, plus pi x squared. Okay, so let's simplify this. So that's going to be equal to 90x minus 2 pi x squared plus pi x squared, which finally is going to be equal to 90x, and we can simplify the minus 2 pi x squared plus pi x squared is going to be minus pi x squared, which, if we look at this, is the same, and therefore k is 90. Part B. Use calculus to find to 4 significant figures the value of x for which s is a maximum, justifying that this value of x gives a maximum value of s. So we know our function is s equals 90x minus pi x squared. So to find a maximum or minimum, well, in this case we know we need to find a maximum, you would differentiate the function and set that equal to 0. So the gradient is 0 on the maximum or minimum of a function or of a curve. So if we differentiate this, ds by dx rather than dy by dx, because our function is s equals, but it's the same thing, we get 90 minus 2 pi x, and then we're going to set this gradient function, ds by dx, equal to 0, so the gradient is equal to 0, and find the value of x for when this gradient is equal to 0. So rearrange this. 90 is equal to 2 pi x, so therefore x is equal to 90 over 2 pi, which gives us a value to 4 significant figures of 14.32. Now, to justify whether this is a maximum or minimum, although in this case we know it's going to be a maximum, we can find d2s by dx squared, d2s by dx squared, which means we need to differentiate our function again. So we're going to differentiate this, which is ds by dx. So that's going to give us minus 2 pi, which is a negative. Okay, so therefore if it's less than 0, it tells us that is enough justification that it is a maximum point. Because d2s by dx squared is negative, minus 2 pi is a negative value, that tells us it must be a maximum point. If d2s by dx squared had come out as a positive, greater than 0, that would tell us it's a minimum point. But because it's a negative, we know it must be a maximum point. The other method you could have used to justify whether it was a maximum or minimum would have been to find the gradient at either side of this value of x. So we know, if you imagine the curve looks like this, and we found the value of x, 14.32, of this point here. Okay, so this is 14.32. So the other way you could do it, if you didn't find d2s by dx squared, would be to find the gradient at this point. So you could put in a value of perhaps x equals 14, just less than 14.32, and you would find that the gradient is positive. And if you put in just after this value, so 14.5 for example, you would find the gradient is negative. So if the gradient has changed from positive to negative, that would also justify that it is a maximum point. Part C. Find to the nearest whole number the maximum value of s. So we have found the value of x for which s is a maximum. Did that in part B. And we also know the function for s equals 90x minus pi x squared. So we simply need to substitute in 14.32 into our function. So s max is going to be equal to 90 times our value of x minus pi times our x squared, and that gives us a value of 645. Question 7a. Solve in degrees to 1 decimal place 3 cos theta plus 5 multiplied by 5 sine theta minus 3 is equal to 0. So we know if this is going to be equal to 0, either this bracket or this bracket must be 0. So we can set 3 cos theta plus 5 equal to 0 and solve. So 3 cos theta equals minus 5, cos theta equals minus 5 over 3. Now you should notice from this, cos theta equals minus 5 over 3. We know when you sketch the sine and cos curves, they go between a value of 1 and minus 1. So cos theta equal to minus 5 over 3 doesn't work. Okay, so we need to say not this value, because cos theta cannot be less than minus 1. So hopefully if we try the other one, 5 sine theta minus 3 equals 0, we're going to get a value between 1 and minus 1. So 5 sine theta is equal to 3, sine theta is equal to 3 over 5, which is less than 1. It is 0.6, so this is an acceptable value. if we put sine to the minus 1 of 3 over 5 into our calculator, we get the value for theta, which is 36.9. Now you need to be aware there's possibly more than one answer when you do a question like this. So the best way to visualize this, to check if we need another answer, is to draw the graph. So because we're doing the sine function, let's draw the graph of sine that starts at 0. And it says in the question we need to look at the values between 0 and 180. Now with the sine graph, this part here is 180 degrees. So this part here is 360 degrees. And the value of sine theta is 3 over 5, which is 0.6. Now the sine graph goes up to 1. So if we go up to 0.6, if I was to zoom in to this graph, there would be two values between 0 and 180. One value here and one value here. So we've only got one of the values, so we need to get the other one. So if the first value is 36.9 degrees, we need to put or theta equals this second value here, which would be 180 minus 36.9, which would be 143.1 degrees. B. Show that the equation 8 sine of x minus alpha equals 3 sine of x plus alpha. So both of these are going to require the double angle formula from the formula booklet. So here they are, copied and pasted from the formula booklet. Now the first one is sine of a minus b. So this bit here, we're going to use this one up here. And the second one is sine of a plus b. So we're going to use this one here. The a and the b replaced by x and alpha. So 8, and then I'm going to replace the sine of x minus alpha with the double angle formula. So bracket, because it's 8 times all of this, sine a, which is x, cos b, which is b is alpha, minus cos x sine alpha. Close bracket is equal to 3 multiplied by sine of x plus alpha. So sine of x plus alpha, or a plus b, we're going to have to use this one here. So 3, open bracket, sine x cos alpha plus cos x sine alpha, and close bracket. Now let's simplify. So we're going to get 8 sine x cos alpha minus 8 cos x sine alpha is equal to 3 sine x cos alpha plus 3 cos x sine alpha. Right, so I'm trying to get down to 5 tan x equals 11 tan alpha. I can simplify this because I have some like terms. 8 sine x cos alpha, we have 3 sine x cos alpha, so they're both sine x cos alpha terms. And this one here, cos x sine alpha, cos x sine alpha. So if I bring it all onto the left hand side, I've got 8 sine x cos alpha minus 3 sine x cos alpha, so that's 5 sine x cos alpha. And then I've got minus 8 cos x sine alpha minus 3 cos x sine alpha, so it's minus 11 cos x sine alpha equal to 0. Okay, so we're getting closer to this. I've got the 5 and the 11. To get tan, you need to know that sine x, I'll write it here, sine over cos, whether it's x or alpha, doesn't matter, is equal to tan. So if I'm going to end up with tan, I know I need to divide by cos. So if I divide all of it through by cos x, I will end up, so write that here, divide by cos x. So I'm going to divide both terms by cos x. I'm going to get 5 5 sine x divided by cos x gives me the tan x cos alpha minus, and cos x over cos x, they're going to cancel, so that's going to be 11 sine alpha equals 0. Now, I can now divide through by cos alpha, as that's going to give me the tan alpha that I need in this second term, and it's also going to cancel with this first term. So 5 tan x cos alpha divided by cos alpha is just 1, so that cancels, minus 11 tan alpha equals 0. And then to write it how it is in the question, take the 11 tan alpha over to the other side, so we've got 5 tan x equals 11 tan alpha. Part C, hence solve to 1 decimal place 8 sine blah blah blah. So this question here is the same as this here, okay? They've just replaced x with 2y, so I can write that down. So x equals 2y, and alpha is 30. And you can see they've done exactly the same thing with the second part. They've got 3 sine of x, which is still 2y, plus alpha, which is 30. So we know we need to just replace x with 2y and alpha with 30. And it says hence solve, so we're going to use what we've just found in part B. So we've got 5 tan of x, which is now 2y, equals 11 tan 30. And we just need to solve this for y. So we get tan of 2y equals 11 tan of 30 over 5. Just write this on the next page. So this 11 tan of 30 over 5 will just give us a value. So if we can do tan to the minus 1 of 11 tan 30 over 5 on our calculator, that will tell us what 2y is equal to. So if we do that, 2y is equal to 51.78 degrees. And also, remember there could be more than one value, so let's have a look. The question says between 0 and 180. Now the tan graph repeats itself every 180 degrees. So if we add on 180 degrees to this, we end up getting 231.78. Now I know that's outside of the 0 to 180, but that's what 2y is equal to. So when we half it, it then is less than 180. So now y is going to be equal to 51.78 divided by 2, which is 25.9 to 1 decimal place, or 231.78 divided by 2 is 115.9, also to 1 decimal place. Question 8a. Solve 5p squared minus 9p plus 4 equal to 0. So it's a quadratic that we can try to factorize into 2 brackets. To get 5p squared, we're going to need 5p and p. That's the only combination. To get the 4 on the end, 2 times 2 or 4 times 1. It's going to be 4 times 1. Both negative. That will give me my minus 9p in the middle. So therefore p is equal to 4 over 5 and 1. Part B. Hence solve 5 to the power of 2x plus 1 minus 9 multiplied by 5 to the power of x plus 4 equals 0. Give your answers to 3 significant figures where appropriate. So they have replaced p with 5 to the power of x. You can see that clearly from this second term. The first term is a little bit harder to spot, but 5 to the power of 2x plus 1 is equal to 5 to the power of x multiplied by 5 to the power of x. If you simplify that, you get 5 to the power of 2x multiplied by 5. That gives you the plus 1. So 5 to the power of 2x plus 1 is equal to 5 to the power of x times 5 to the power of x times 5. So it is, part B is the same as part A. P has been replaced by 5 to the power of x. So using part A, if we replace P, we can say it's equal to 4 over 5, and we can say 5 to the power of x is equal to 1. Right, the second one is easiest to solve for x. Anything to the power of 0 equals 1, so therefore x must be 0 in this case. The first one, we can take natural logs of both sides of this, so we get ln of 5 to the power of x equals ln of 4 over 5. And then using the rules of logs, we can bring this x, the power, to the front. So we get x ln 5 equals ln of 4 over 5. And then x is therefore equal to ln of 4 over 5 over ln of 5. And they are just values, they are just numbers if you type them into a calculator. So type that into a calculator and you'll get a value for x of minus 0.139 to 3 significant figures. Part C. The curve with equation y equals 5 to the power of 2x plus 1 plus 5 to the power of x intersects the curve with equation y equals 2 to the power 2 times 5 to the power of x plus 1 minus 4 at 2 points. Find the coordinates of each of these 2 points. So when two functions or curves intersect each other, we are going to put them equal. So we can put 5 to the power of 2x plus 1 plus 5 to the power of x equal to the other curve, which is 2, 5 to the power of x plus 1 minus 4. And try to solve this. Now it looks fairly similar to part B. We've got the 2x plus 1 term, and we've got 5 to the power of x, but on this side we've got 5 to the power of x plus 1. So if we change the right hand side, we'll leave the left hand side the same, plus 5 to the power of x equal, well, 5 to the power of x plus 1 is equal to 5 to the power of x times 5. So I've got 2 times 5 times 5 to the power of x minus 4. So then if we rewrite it one more time, we've got 2 times 5 is 10 times 5 to the power of x minus 4. So now on the left hand side we have 1, 5 to the power of x, and on the right hand side we have 10. So if we take it all to the left hand side, we get 5 to the power of 2x plus 1. I'm going to subtract 10 lots of 5 to the power of x, so we get minus 9 lots of 5 to the power of x plus 4. So I take the minus 4 onto the other side as well, equal to 0. And now that equation there is exactly the same as part B. And we've already solved part B to get our two values of x. And we got x equals 0 and x equal to minus 0.139. So what we need to do is find the two coordinates, therefore we need to find the two y values. So I can put x equals 0 into either of my two equations from the question. So I'm going to put it into the first equation. So y equals 5 to the power of 2x plus 1 plus 5 to the power of x. So therefore, if we put x into there, we get y equals 5 to the power of 1 plus 1. Therefore, y is 6. So when x is 0, y is 6. And if I put my second value in, we're going to have to use a calculator for that one. However, if we look back at part B, we got, before we solved for our x, we were at 5 to the power of x equals 4 over 5. So if I rearrange this equation, which we've done before, into y equals, that 5 to the power of 2x plus 1 is 5 to the power of x times 5 to the power of x times 5 plus 5 to the power of x. And I know 5 to the power of x is 4 over 5. So I can do this without a calculator. If I replace 5 to the power of x with 4 over 5 times 4 over 5 times 5 plus 4 over 5, and that simplifies to 4. So there were two ways. You could have done it this way by splitting it up and replacing 5 to the power of x with 4 over 5, or you could also have substituted this value in just like we did with x equals 0 and got your value of y. So we've got 0, 6, and when we substituted in minus 0.139, we got a y value of 4. Question 9. A. Solve the equation 2 log to the base p of 9 plus 3 log to the base 3 of p is equal to 8. So we have an equation with two log terms. However, the base of each of the log terms is different, so we're going to need to change the base of one of the log terms. So if we write the first term in terms of log to the base p, and we can change this base using the formula from the formula booklet, which is log to the base a of b is equal to log to the base x of b over log to the base x of a. So this formula is in the formula booklet. The b is the big number, it goes on the numerator, and the base, the a, goes on the denominator, and this x can be any base we want. So we're going to choose the base of 3 so that we can match this first term with this second term, so they've got the same base. So we're going to rewrite 2 log to the base p of 9 using that formula as 2 log to the base p of 9 can be written as log to the base 3 of 9 over log to the base 3 of p. And if we look at the top, we've got log to the base 3 of 9. So the question for that is 3 to the power of what gives us 9? So that would be 2. So log to the base 3 of 9 is just 2. So the numerator, so log to the base p of 9 is equal to 2 times 2, because log to the base 3 of 9 is 2, divided by log to the base 3 of p. So we've rewritten that first term, 2 log to the base p of 9, as 4 over log to the base 3 of p. Now if I substitute that back into my original equation, I've got 4 divided by log to the base 3 of p plus, I'm just copying the equation from the question, 3 log to the base 3 of p is equal to 8. Now my equation has both terms with log to the base 3. So what I can do here is multiply through by log to the base 3 of p, which will give me 4 plus 3 times log to the base 3 of p all squared equals 8 log to the base 3 of p. Then this looks like a quadratic equation. Rather than x, we have log to the base 3 of p. So if I just do a quick substitution and write log to the base 3 of p is equal to x, then that will be easier to spot. So that is 4 plus 3x squared is equal to 8x. Put it all on the same side, so I get 3x squared minus 8x plus 4 is equal to 0. Attempt to factorize it so we can solve it. We're going to need 3x and x, and then it's going to be 2 and 2, and they're both going to be negative, and that's equal to 0. So therefore x is equal to 2 over 3 and 2. However, we use the substitution log to the base 3 of p is equal to x. So if x equals that, we can say log to the base 3 of p is equal to 2/3 and 2. So if we solve these separately, let's solve log to the base 3 of p is equal to 2/3. So what that's asking is 3 to the power of 2/3 is equal to p. And we know 3 to the power of 2/3 is 3 squared, which is 9, and then cube rooted. So it's the cube root of 9. And then if we want to solve the second one, because we've got two answers here, we've got log to the base 3 of p is equal to 2. So that's saying 3 to the power of 2 is equal to p, and therefore that must be 9. So our answers for p are cube root of 9 and 9. Part B. Given that log to the base 2 of 3 is equal to log to the base 4 of 3 to the power of k, find the value of k. So I'm going to try to get this first term on the left hand side to look something like this term on the right hand side. So again, I'm going to need to change the base to have a base of 4 so it can match the right hand side. So log to the base 2 of 3, using the same formula from part A, changing the base of a log, that remember is in the formula booklet, will be log to the base 4 of 3 over log to the base 4 of 2, which equals, if you look at that denominator, log to the base 4 of 2 is asking the question 4 to the power of what gives us 2. Well, that would be 4 to the power of a half, because the square root of 4 is 2. So the denominator, if I just rewrite the numerator first, and then the denominator is a half, because log to the base 4 of 2 is equal to a half. So this can be rewritten. If you're dividing by a half, you're multiplying by 2. So this can be rewritten as 2 log to the base 4 of 3. And using the rules we know for logs, we can take this 2 up to make it a power. So therefore this is equal to log to the base 4 of 3 squared. And if you compare that to what we're asked in the question, log to the base 4 of 3 to the power of k, so therefore k is equal to 2. Part C. Show that this left hand side is equal to this right hand side. So on the left hand side we got some terms in log to the base 4, log to the base 2, log to the base 4, log to the base 2, and we want to simplify all this to make it look like this. So we need our answer to be in terms of log to the base 4. So we can use what we were given in the question, that log to the base 2 of 3 is equal to log to the base 4 of 3k. That's told to us here in the question. So I'm just going to rewrite what part C says, but I'm going to replace all the log to the base 2 with log to the base 4. So I've got 6x log to the base 4 of x minus 3x, and I'm going to replace this log to the base 2 of 3 with log to the base 4 of 3k minus 5 log to the base 4 of x plus 10 log to the base 4 of 3 to the power of k. And that's it. So now we're going to try and simplify this and get it to look like this. Now we have all in log to the base 4. What I'm going to do is bring up these coefficients and put them as powers. So I can rewrite the first one as log to the base 4 of x to the power of 6x minus log to the base 4 of 3 to the power of 3kx, but we found the value of k in part B. K was equal to 2, so that's going to be 3 times 2 times x, so that's 6x, subtract log to the base 4 of x to the power of 5 plus log to the base 4 of 3. K we know is 2, so that's going to be 2 times 10, which is 20. So now we're going to simplify log to the base 4 of x to the power of 6x. When you're subtracting a log, so this one here, I'm working with these x terms first. When you're subtracting a log, you divide. So I'm going to divide by x to the power of 5. And then I'm going to work with the log to the base 4 of 3. So this term here is 3 to the power of 20, that's a positive. And then this term here, log to the base 4 of 3, is a negative, so that means this part is divide. So that's going to go on the bottom. 3 to the power of 6x. Now I'll simplify that. So we know when you're dividing indices, such as this bit and this bit, you can write subtract. So we've got log to the base 4 of x, 6x subtract 5, plus log to the base 4 of 3 to the power of 20 subtract 6x. Right, so now I'm going to write that as one term, so that's going to be log to the base 4. I am adding these logs, this log plus this log, which means I need to multiply what is in the brackets. So I'm going to get x to the power of 6x minus 5 multiplied by 3 to the power of 20 minus 6x, which is close but not quite what we have in the question. So I need to bring this 3 to the power of 20 minus 6x onto the bottom. So if I'm finding the reciprocal of this, or I want to put it on the bottom, the numerator, the denominator of the fraction, I need to write the power as a negative, so it'd be minus 20 plus 6x. So I've got log to the base 4, the x stays the same, 6x minus 5, and on the bottom I've got 3, but I need to write 6x minus 20. And that is exactly the same as what we have in the question. I'm able to write this 3 to the power of 20 minus 6x as a denominator because I have changed the sign of the power. The minus 6x has become positive 6x, and the 20 has become minus 20. Question 10a. Expand 1 plus 2x squared in brackets to the power of minus 1/3 in ascending powers of x up to and including the term in x to the power of 6, expressing each coefficient as an exact fraction in its lowest terms. Okay, so this is a binomial expansion question. When the power of the binomial expansion is a negative or a fraction, we need to use the formula from the formula book. So I've copied and pasted it here. And if we compare this formula 1 plus x to the power of n with the question, we can see that x equals 2x squared and n, which is the power, is equal to minus 1/3. So I'm just going to substitute into this binomial series formula. So the question is 1 plus 2x squared to the power of minus 1/3 is going to be equal to 1 plus minus 1/3 times x plus n, which is minus a third, n minus 1, which is minus 4/3, all over 2 factorial, which means 2 times 1, so that's just 2, x squared, so be careful here, x is 2x squared, and that is all squared. If I expand out this bracket, I'm going to get x to the power of 4. The question says x to the power of 6, so I need one more term, plus n, which is minus a third, n minus 1, minus 4/3, n minus 2, which is minus 7/3, all over 3 factorial, which is 3 times 2 times 1, which is 6, multiplied by x cubed, so the power of x will go up for each term. So the last term was x squared, this time is x cubed, the next one would be x to the power of 4. So again, be careful to put the x in a bracket, 2x squared all cubed. Now if we simplify this, 1 plus minus a third times 2x squared will give us minus 2x squared over 3. Just this out, and the next term, if we simplify, so we multiply the fractions on top over 2, and be careful to square the 2, which will become 4, and square the x squared, which will become x to the power of 4. We get 8x to the power of 4 over 9. Subtract for the final term. Be careful to cube this, so 2 cubed will be 8, and x squared cubed will be x to the power of 6. So that final term will simplify to be 112 x to the power of 6 over 81. Part B. State the range of values of x for which your expansion is valid. So we are expanding 1 plus 2x squared to the power of minus a third. For it to be valid, we need it to converge to a certain number. If it diverged, that means the value of our expansion would just get bigger and bigger and bigger. Okay, so we need it to converge. So for it to converge, we need this value to be a fraction, to get smaller and smaller and smaller. So this value of 2x squared must be less than 1, or it must be greater than minus 1. Okay, otherwise our expansion will not converge. So we can rearrange this to say x is less than 1 over root 2, or x is greater than minus 1 over root 2. And you can write that as one inequality, so therefore x is less than 1 over root 2 and greater than minus 1 over root 2. So it's all about making this part of the expansion less than 1 and greater than minus 1, so that our expansion converges. Part C. Obtain a series expansion for f of x in ascending powers of x up to and including the term in x to the power of 6. Give each coefficient in terms of k where appropriate. So we need to do this expansion, and if we relate this to part A, this is the same as 2 plus k x squared multiplied by what we did in part A, which is 1 plus 2x squared to the power of minus 1/3. Okay, so the only difference here is this 1/3 I've changed to be a minus, okay, because it was a denominator. So we've already expanded out 1 plus 2x squared to the power of minus 1/3 in part A up to the powers of x to the 6, and we got 1 minus 2x squared over 3 plus 8x to the power of 4 over 9, subtract 112 x to the power of 6 over 81. So I just need to multiply all of this by 2 plus kx squared. So starting by multiplying each of these terms by 2, 2 minus 4x squared over 3 plus 16x to the power 4 over 9, subtract 224 x to the power 6 over 81. Okay, then I'm going to multiply each of these terms by kx squared. However, because I have an x squared, I only need to multiply up the first term, second term, and third term, because that will then go up to x to the power of 6. If I multiply this one by x squared, I will get x to the power of 8, so I don't need that one. So plus 1 times kx squared is kx squared, plus, so it's actually going to be a minus 2k x to the power 4 over 3 plus 8k x to the power 6 all over 9. So simplify this by collecting like terms. I've got 2 plus, and let's look at the x squared terms, this one and this one. So it's going to be k minus 4 over 3 x squared plus, if we now look at the x to the power 4 terms, I've got 16 over 9 minus 2k over 3 x to the power 4, and then finally the x to the power 6 terms, I've got 8k over 9 minus 224 over 81 x to the power of 6. Part D. Given that the coefficient of x to the power 4 in the series expansion of f of x is 0, find the value of k. So our expansion of f of x from part C was this, and we know that the coefficient of x to the power 4, 16 over 9 minus 2k over 3, is equal to 0. So we can rearrange this to say 16 over 9 is equal to 2k over 3. And then if I multiply both sides by 3, divide by 2, so I solve for k, I get the answer of k is equal to 8 over 3. Part E. Hence, use algebraic integration to obtain an estimate to 4 decimal places of the integral of f of x between 0 and 0.5. So I've now found k, so I can substitute my value of k into my expansion of f of x, which will give me f of x is equal to 2 plus, now if I substitute k into here, I end up getting 4 over 3 x squared. I know the coefficient of x to the power of 4 is 0 because it told me that in part D. That's how I found k. So there's going to be no x to the power 4 term, plus substituting k into the x to the power 6 term, that gives me minus 32 over 81 x to the power of 6. So substituting in k, that is what f of x equals. So now if I continue up here, I need to integrate between 0 and 0.5 my f of x, which is 2 plus 4/3 x squared minus 32 over 81 x to the power of 6. So integrating this, I get 2x plus 4x cubed over 9 minus 32 x to the power of 7 divided by 567 between 0.5 and 0. Now if I substitute 0.5 into this, I get 2 times 0.5 plus 4 over 9 multiplied by 0.5 cubed, subtract 32 over 567 multiplied by 0.5 to the power of 7, and then if I then need to subtract the expression with 0 substituted in, but if I substitute 0 into each of these terms, I will get 0, so I just need to subtract 0, so I won't write that down, and this is equal to roughly 1.0551. Question 11. The curve C has equation 3y is equal to x squared plus 2. The point P lies on C and has x coordinate 4. The line K is the tangent to C at P. Part A. Find an equation for K, giving your answer in the form ay equals bx plus c, where a, b, and c are integers. Okay, so we know the curve has equation 3y is equal to x squared plus 2. So first thing I'm going to do is rearrange this to say y equals. So I'm going to divide every term by 3, so that's going to be a third x squared plus 2 over 3. Now the point P has x coordinate 4. So I can simply find the coordinate of P by substituting in this x into the curve, and that will give me y. So if I substitute 4 into either of these, because they're both the same, I'll substitute into this one. 4 squared is 16, plus 2 is 18, and then divide that by 3 gives me 18 over 3, which is 6. So the point P is 4, 6. We now need to find the line K, which is a tangent to C, which means it has the same gradient because it's a tangent at the point P. So we need to find this gradient. Now to find the gradient, we need to find the gradient function, which means we need to differentiate our curve. So differentiating y equals a third x squared plus 2 thirds gives us 2 thirds x, and if I substitute in my value of x at this point P to find the gradient, I get the m, which is the gradient of the tangent, so I'll put mt, is equal to 2 thirds times 4, which is equal to 8 over 3. So now we just need to find the equation of the tangent, the line K. So we know K is going to be in the form y equals mx plus c, because it's a straight line. And we have y for my coordinate P. We have the gradient, which is 8 over 3. We have x for my coordinate P. So we just need to find c. So substituting in, we have 6 equals gradient, which is 8 over 3, multiplied by 4 plus c. So 6 is equal to 4 times 8, which is 32 over 3, plus c, and therefore we know c is equal to minus 14 over 3. So finally we just need to make sure we write the answer in the form ay equals bx plus c, ensuring a, b, and c are integers or whole numbers. So if we write it in the form y equals mx plus c, because we've now found c, we know y is equal to 8 over 3, the gradient x, plus our c, which is minus 14 over 3, and then we'll rewrite that all as integer coefficient, so we need to multiply through by 3. So we get 3y is equal to 8x minus 14. Part B. The line L is the normal to C at P. Find an equation for L, giving your answer in the form dy equals ex plus f, where d, e, and f are integers. So it's at the point P, so we can use the same coordinate we used in part A, which we know is 4, 6. But this one is the normal. So the gradient of the tangent is equal to 8 over 3, which means we know the gradient of the normal, which is perpendicular or a right angle to the tangent. So m of the normal, n, so the gradient of the normal is equal to the negative reciprocal, so minus 3 over 8. So change the sign and flip the fraction. So we now have the gradient of this normal, and we have a point on this normal curve. So similar to part A, we know the normal is going to be in the form y equals mx plus c, because it's a straight line. So substituting in our x, our y, and our new gradient, we can find the equation of this line. So 6 is equal to minus 3 over 8 multiplied by 4 plus c. So 6 is equal to minus 12 over 8 plus c, which gives us a value for c of 15 over 2. So if we now substitute our gradient and our c into this equation of a straight line, we get y equals the gradient of the normal, which is minus 3 over 8, x plus our c that we just found, and that is the equation. However, we need to make sure all the coefficients are integers, so we can rewrite this. If we multiply each term by 8, we get 8y is equal to negative 3x plus 60. Part C. Find the area of the triangle bounded by the line K, the line L, and the x-axis. Okay, so let's sketch it to see what we're looking at. So from the previous parts, we know the line K has the equation here from part A, so 3y equals 8x minus 14. Now I'm just going to rewrite that as y equals, so it's easier to sketch. So y is equal to, divide everything through by 3, so 8 over 3x minus 14 over 3. And then we also know from part B, the line L has the equation 8y is equal to minus 3x plus 60. And again, I'm going to rewrite this as y equals, so it's easier to sketch. So minus 3 over 8x plus 60 over 8. So the question has asked us for the area bounded by these two lines and the x-axis. So I'm going to draw them on a graph just to have a look. So if we look at this first one, y equals 8 over 3x minus 14 over 3. So it has a positive gradient, so it's going to go uphill, and it's going to intersect the y-axis at roughly minus 4. So it's going to look something like this. And the second one has a negative gradient, and it's going to intercept the y-axis at roughly 8. So that is going to look like this. And we want to find this area in here, which is obviously a triangle, and we also know it's a right angle triangle because these two lines are perpendicular. So we need to find the base and the height. Now we know the base is the difference between this point and this point, and the height is 6 because this is the point P, which we have found the coordinates from the previous part is 4, 6. So therefore we know the height of the triangle is 6, so we just need to find this distance here, which is the base. So to find the base we need these two coordinates. So for each of the lines I can set y equal to 0, and that will find me these two coordinates. So for the first line, if I put y equal to 0 for this equation, I get 0 equals 8 over 3x minus 14 over 3. So I'm trying to solve for this value of x, which will be this point here. And if I rearrange this, I get x is equal to 7 over 4. Now if I do the same thing for this second line, put y equal to 0, which will find me this coordinate here. 0 is equal to minus 3 over 8x plus 60 over 8. And if I rearrange that, I will find that x is equal to 20. So therefore the difference between this point and this point is 20 subtract 7 over 4, which gives me 73 over 4, and therefore that is the base of my triangle. So the area is going to be base, which is 73 over 4, times height, which is 6, because we know this point here is P, so this height must be 6, times 1/2, because it's a triangle, which gives me an answer of 54.75. Part D. The finite region bounded by C, the line L, the x-axis and the y-axis is rotated through 360 degrees about the x-axis. Use algebraic integration to find, to the nearest whole number, the volume of the solid generated. Okay, so first let's sketch what this looks like. So the curve C has equation 3y equals x squared plus 2. So I'm going to write that in the form y equals 1/3 x squared plus 2 over 3. Secondly, the line L we can get from the previous part. The line L is y equals minus 3 over 8x plus 60 over 8. Y equals minus 3 over 8x plus 60 over 8. So now we need to sketch them on a graph just to see what this is going to look like. So firstly, let's sketch this quadratic curve here. So it's a positive quadratic, which means it's a U shape, and it crosses through the point 2, 3. So we know it's a U shape that crosses on the positive y-axis. We need to know, is it going to cross the x-axis? So is it going to have any roots? So quickly to find that, if we just do b squared minus 4ac, which is the discriminant, and if that is more than 0, it's going to have 2 roots. If that's 0, it's going to have 1 root, and if it's less than 0 or a negative, it's going to have no roots. So quickly, it's going to be b squared. Well, there's no x term in here, so that's just going to be 0 squared minus 4 times a, which is 1/3, times c, which is 2/3, and that is going to be 0 minus 4 times these. So that is clearly a negative. Okay, so that is less than 0. So therefore there's no roots. So we know the curve doesn't cross the x-axis, goes through the point 2, 3, and is a U-shape because it's positive. So it's going to look something like this. Now let's sketch this straight line. It's a negative gradient, so it's going to go downhill, and it crosses through roughly 8, so it's going to look something like this. Now, we also know this point here is P, because we've used that previously in this question, and we know the coordinate of P from the previous parts was 4, 6. So that's this point here is 4, 6, and we want to find the volume of the solid generated. So the solid that we have, if I just zoom in here, is going to be this section. Now this section is made up of the area under the curve, this part, plus the area under this straight line. So what we're going to need to do is the area under the curve rotated. If I just remove this, we're going to need to find integrate pi y squared between 0, so this part here, x is 0, and here. So we know x is 4 at that point because that point is P, plus the area of this bit, which if it's rotated around the x-axis will be a cone. So plus the cone between an x value of 4 and wherever this crosses, which we have found previously is actually 20. We found that when we found the area of the triangle. So let's start with integrating between 0 and 4. Take pi out because that's a constant. Y squared. So that's 1/3 x squared plus 2/3 all squared, because when we're rotating about the x-axis we do pi y squared, similar to the area of a circle, which would be pi r squared, but our radius is just the function y, plus the volume of the cone, of which the formula is 1/3 pi r squared times the height. So again, the radius is going to be from this x-axis to this point here, the radius of my cone. If you picture it, it's going to look something like this, 3D version of that. So the radius is from this x-axis to P, which is 6. So it's going to be 1/3 times pi times 6 squared times the height. Now the height of this cone is from this point to this point. Now if you remember in the previous question we found where this line crossed the x-axis and it was at a value of 20. So this coordinate here is 0, 20. So the height of my cone is from this point to this point, which is 4 to 20. So the height is 16. Okay, so now, and we're only integrating this section. We're not integrating this cone. So we'll leave the cone till the end. So let's square our function. So 1/3 x squared plus 2/3. Now if we square that, we're going to get 1/9 x to the power of 4 plus 4x squared over 9 plus 4/9 dx, and then remember to plus the cone on the end. To make this a bit simpler, we can take out 1/9 as a common factor, and because it's a constant, we can bring it out the front of our integration. So we've got pi over 9, pi times 1/9, integrating between 4 and 0, x to the power 4 plus 4x squared plus 4 dx. You don't need to take out the 1/9, but it will make it a little bit easier to integrate, and then plus the cone, the area, the volume of the cone on the end. So that is going to be equal to pi over 9, integrating our function, we get x to the power 5 over 5 plus 4x cubed over 3 plus 4x between 4 and 0 plus the cone. And if you now substitute in 4 into all of this and then substitute in 0, if you substitute in 0, it's just going to be 0, so we only need to substitute in 4. We get pi over 9 multiplied by 4 to the power of 5 over 5 plus 4 times 4 cubed over 3 plus 4 lots of 4, close that bracket, plus the cone, which we've already figured out up here, is 1/3 times pi times 6 squared, which is 36, times 16. And if you work all that out on a calculator, you get the volume to be 710.